Hello students, today discussion is about hybridization in organic compounds. So hybridization is a concept related to chemical bonding. So in brief, I'll explain what is hybridization, how does it takes place, how to find the hybridization of carbon in organic compounds. So let's start the discussion. First, what is the configuration of carbon, students? The configuration, electronic configuration of carbon is 1s2, 2s1, 2p3. In this configuration, the valence shell configuration is 2s1, 2p3. We all know that carbon's valency is 4. There are 4 valence electrons. Its valency is 4. It forms 4 bonds. Yes or no, students? So let's take one example. One compound. The example is methane. CH4. Yes or no? So how many hydrogens are there, students? In methane? In methane there are 4 hydrogen atoms. So there are 4 electrons are there. Yes or no? Each electron bonds with electron of hydrogen. So total how many bonds will form? Methane will form how many bonds total? Total 4 bonds, and all the 4 bonds in methane are sigma bonds. Yes or no, students? All the bonds in methane are sigma bonds. Sir, how to identify sigma bond or pi bond? Remember that this comes under valency bond theory, but in shortcut I'll explain. In between any 2 atoms, the first bond is sigma. If there is if it's a multiple bond, definitely it's a pi bond. For example, carbon single bond carbon. How many bonds are there? 1 bond. So what is the bond? It is sigma. If carbon double bond carbon, how many bonds are there? 2 bonds are there. The first bond is sigma, second bond is pi. C triple bond C, how many bonds are there? 3 are there. The first bond is sigma, remaining 2 are pi bonds. Like that you can identify. So here if you can see, students, in this example of methane, how many bonds are there? 4 bonds are there. 4 bonds means 1 bond is sigma, remaining all are pi bonds. No, what I told you, in between any 2 atoms, the first bond is sigma, between this carbon and hydrogen. How many bonds are there? Only 1 bond. So what is the bond, students? Sigma. Between this carbon hydrogen, only 1 bond. Sigma. Between this carbon hydrogen, sigma. Between this carbon hydrogen, sigma. Is it clear? All the 4 bonds in methane are sigma bonds. Okay, the concept is clear. But here, what is this hybridization? Hybridization means, students, hybridization takes place before the chemical bonding, before the bond formations with hydrogens. Why it takes place? I will show you. I'll explain. Listen. Carbon forms 4 bonds. Yes, sir, students. All these 4 bonds coming from 4 electrons. These 4 electrons are present in which orbitals? You can see 1 electron is present in the s orbital. 3 electrons are present in the p orbitals. Yes, sir. So one of the sigma bond is overlapping between s orbital of carbon and s orbital of hydrogen. Is this point clear? S orbital of carbon. Hydrogen configuration is 1s1 only, so it's the electron present in the s orbital. Is the point clear? Next, second bond, second sigma bond, it is between p orbital of carbon, s orbital of hydrogen. Yes or no? And next bond, p orbital of carbon, s orbital of hydrogen. This one. Fourth bond, p orbital of carbon, s orbital of hydrogen. Is the point clear? Carbon forms 4 sigma bonds, 4 single bonds in methane. Out of all these 4 single bonds, are the overlapping same? The overlapping between the orbitals same? No. 1 sigma bond between s and s overlap. Remaining 3 sigma bonds between s and p overlap. So, sir, what's the problem here? The problem here is, students, bond strength. The problem is bond strength. Do all these bonds have equal bond strength? What do you think? Do all these bonds do they have equal bond strength? Bond strength means ability to break the bond. The temperature required to break the bond is bond strength. Do all these bonds have equal bond strengths? The answer is no. In a molecule, if all the bonds doesn't have equal bond strengths, then the molecule is not stable. Not 100% stable. We all know all the molecules want to get some kind of extra stability. Whatever it may be. Some kind of extra stability. So, here to get this extra stability, what is extra stability meaning? The molecule want to get the bond strength equal in all the bonds. The molecule want to get the bond strength equal for all the 4 bonds. Sir, how it is possible? It is possible. You know how it is possible? Before the bonding only, that means before the bonding only, 1 s orbital, 3 p orbitals are there, students. All intermix. All these orbitals completely intermix and they form new set of orbitals. That new set of orbitals are like this. In these orbitals, can you identify where is s orbital? Can you identify where is p orbital? No. How many orbitals are intermixing? 1 s orbital and 3 p orbitals, right? So this orbital is called as sp3. 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 After formation of these hybrid orbitals, then hydrogen bonds. Understood? Understood? Now listen. Now look at here. The sigma bond only between s orbital of hydrogen and what is orbital now of carbon? sp3. It's no more s, no more p. Here s orbital of hydrogen and what is orbital name now? sp3. Here s and sp3. Here s and sp3. This is the concept. Understood? Now all the bonds, do they have equal bond strengths? Yes or no, students? Yes, they have equal bond strengths. Why? Because sigma bond. What are the orbital combinations? S and sp3. S and sp3. S and sp3. S and sp3. Now all the each and every orbital has equal bond energies. They have equal energies. So what is hybridization is the intermixing of atomic orbitals in order to equalize their energy. Sir, why do we need to equalize? In order to form a molecule which more stable, with having all the bonds having equal bond strengths. When they are having equal bond strengths, when they intermix with each other. Can we say where is s orbital now? Where is p orbital now? Simply we can say sp3. Sir, why it is sp3? Why? Because one s orbital and how many p orbitals involving in hybridization? 3 p orbitals. So hybridization is sp3. Understood? Got the clarity? Now in methane, what is the hybridization of carbon? You can say directly say sp3. Sir, how to find out? Directly molecule is given. Sir, is there any shortcut? Do we need to write everything? Are there any conditions are there? Yes, there are few conditions are there. There are few shortcuts are also there. That we'll discuss now. First, the conditions are only sigma bonding orbitals involve in hybridization. Pi bonding orbitals do not involve in hybridization. Pi bonding orbitals do not involve in hybridization. Sir, why? Pi bond is a weak bond, students. If pi bond also involved, the overall bond strength of the molecule decreases. So that's why pi bonding orbitals do not involve in hybridization. Only sigma bonding orbitals involve in hybridization. This is the point you have to remember. Of course, lone pair of electrons also involve in hybridization. We all know that carbon doesn't have any lone pair of electrons. So students say carbon maximum can form how many bonds? Carbon valency is 4. So carbon can form maximum how many bonds, students? 4 bonds. So 4 bonds, if it forms 4 bonds, definitely it can form 4 sigma bonds. Yes or no? If 4 sigma bonds are there, the hybridization is sp3. Sir, why it is sp3? I already have represented the configuration. Yes or no? 2s1, 2p3. How many s orbitals are there? 1 s orbital. How many p orbitals are there? 3 p orbitals. 4 sigma bonds means 1 s orbital, 3 p orbitals. So sp3. If 3 sigma bonds are there, that means this forms sigma, this forms sigma, this forms sigma, this forms pi. Now what is hybridization? Just count the orbitals. 1 s orbital and how many p orbitals are involving? 2 p orbitals. So what is hybridization? sp2. If 2 sigma bonds only are there in carbon, that means this also form pi bonds, pi bond. Then what is hybridization? 1s and 1p only involving in sigma bonding, right? So what is hybridization? sp. Sir, if only one, it isn't possible. Yes or no? How only one sigma bond is there? Only one and 1 s orbital. So minimum 2 sigma bonds are there. Maximum 4 sigma bonds a carbon can form. So you have to remember this in a shortcut. 4 sigma bonds means what is hybridization? sp3. 3 sigma means what is hybridization? sp2. 2 sigma means what is hybridization? sp. This is a shortcut. Sir, in a molecule how to recognize? How to remember? Sir, in a molecule how to do it? How to find out the number of sigma, number of pi bonds? That also I'll explain. See. Students, let's see 4 examples. Look at the first example which we already practiced once again. What's the formula? CH4. CH4 means how many hydrogens are there? 4 hydrogens. These 4 hydrogens definitely they form sigma bond. Yes or no? Can hydrogen form pi bond? No. Hydrogen cannot form pi bond. Why? Because hydrogen configuration is 1s1. To form pi bond, the electron should be in the p orbital. That is one of the conditions. So wherever there is hydrogen, remember you have to count that hydrogen as a sigma bond. So 4 hydrogens are there. How many sigma? 4 sigma. So say what is the hybridization here? Straight away the hybridization is sp3. Look at here, C2H6. Let us structure the molecule. 2 carbons are there. Okay, 6 hydrogens are there. Here 3, here 3. Now count the number of sigma for each carbon. 1 sigma between carbon. I already have told you, hydrogen definitely forms sigma only. 1 sigma here, 3 sigma with 3 hydrogen. That means what is hybridization? Total how many sigma bonds are there? 4 sigma. So what is the hybridization? sp3. So sp3. And for the other carbon, 1 sigma, 3 hydrogens, 3 sigma, total 4 sigma. So sp3. Understood? Look at the next molecule. C2H4. So first carbon, carbon. How many hydrogens are there? Only 2 hydrogens are there here. Here 2 hydrogens. Can the carbon valence is satisfied? No. That means it should be a double bond between carbon and carbon. Now check. 2 bonds are there, 2 hydrogens. Carbon valency 4. 2 bonds, 2 hydrogens. Satisfied or not? Now let's check the number of sigma bonds. Between these 2 carbons, how many sigma bonds are there? First bond is only sigma. Yes or no? Remaining next bond is pi bond. 1 sigma here. 2 hydrogens, 2 sigma. Total how many sigma? Total 3 sigma bonds are there. So what is the hybridization? sp2. And on the second carbon, 1 sigma, 2 hydrogens, 2 sigma. Total how many? 3 sigma. So what is the hybridization? sp2. That's it. That's the hybridization. Last molecule, C2H2. That means carbon, bond, carbon. 1 hydrogen here, 1 hydrogen here. Carbon valence is satisfied. Now arrange the number of bonds between carbon and carbon. 1 hydrogen is there, 1 bond is there. Total remaining more, how many bonds are there? Should be there? 2 bonds. So it's a triple bond between carbon and carbon. Count the number of sigma for each carbon. This is 1 sigma. 1 hydrogen, 1 sigma. So total 2 sigmas are there. What is hybridization? sp. 1 sigma, 1 hydrogen, other sigma. What is the hybridization? sp. So in the organic compound, students, we can see maximum sp, sp2, sp3 hybridizations only. So you have to practice the shortcuts. The shortcuts are how to find the number of sigma bonds. And you have to remember the hybridization. That's it. If you can find the number of sigma bonds, you can directly say the hybridization. 4 sigma, sp3. 3 sigma, sp2. 2 sigma, sp. Understood? Got the clarity? So students, lastly, look at this big example. So first carbon. How many sigma? There is 1 sigma between carbon, carbon. 3 hydrogens. 3 sigma. Total how many? 4 sigma. Means what is hybridization? sp3. Second carbon. Sigma here, 2 hydrogens. Total 4 sigma. sp3. Third carbon. Sigma here, 2 hydrogens. Total 4 sigma. sp3. Look at the fourth carbon. Sigma. This is pi bond. Double bond means one is pi bond. First bond is sigma, second bond is pi. Total how many? Only 3 sigma. So what is hybridization? sp2. Next, this bond. This carbon, right? 1 sigma, second sigma, 2 hydrogen means 2 sigma. Total 4 sigma. sp3. Look at this carbon. 1 sigma, second sigma, remaining 2 are pi bonds. Only 2 sigma bonds are there. So what is hybridization? sp. Look at the last carbon. 1 sigma here, 1 is hydrogen. Total 2 sigma. So what is the hybridization? sp. That's it. In shortcut, we can easily find the hybridization in organic compounds. I hope you got the clarity, students. Thank you.